Welcome to Leo Academy. Today, we are mastering LeetCode 138. Copy list with random pointer. This is a notorious interview question that tests your ability to manipulate complex pointer structures without using extra memory. Let us look at the problem. We are given a linked list where each node has two pointers, a standard next pointer, and a random pointer that can point to any node in the list, or null. Our goal is to create a deep copy, meaning every single node and its connections must be brand new. A simple pass is not enough because the random pointer might point to a node we have not even created yet. Think of it like a group of friends in a line. Each person has their hand on the shoulder of the person in front, but they are also pointing at a random person in the line with their other hand. To clone this group, we use the shadow twin technique. Each person creates a clone of themselves and has them stand directly behind them. Now, every clone can easily see who their random target's clone should be. Our strategy has three elegant passes. First, we interleave the list by inserting a copy node after every original node. This creates a node clone node clone pattern. Second, we copy the random pointers. If the original node points to X, its clone should point to the clone of X, which is conveniently just X.next. Finally, we separate the two lists by unzipping the next pointers to restore the original and extract our perfect deep copy. Let us dive into the dry run. Look at the screen. We have a list of three nodes, 7, 13, and 11. 7 points to null. 13 points to 7, and 11 points to itself. Pass 1, interleaving. Focus on node 7. We create its clone, 7 prime, and insert it between 7 and 13. Now we do the same for 13, inserting 13 prime. And finally, we insert 11 prime after 11. Notice how each original node is now followed by its own shadow twin. Pass 2, setting randoms. This is where the magic happens. Look at original node 13. Its random pointer goes to 7. Because 7 prime is right after 7. 13 prime can just point to 13.random.next. We apply this rule to every clone. 13 prime points to 7 prime, and 11 prime points to 11 prime. Pass 3, extraction. Now we just need to separate them. We update the next pointers of the original nodes to skip the clones, and update the clones to skip the originals. We carefully unzip the connections, and there it is. Two identical, but independent lists. Now, let us look at the Python code. We handle the edge case of an empty list first. Then, we start our first loop to interleave the nodes, creating a new node object and stitching it in. Next, our second loop sets the random pointers. We check if the original random exists, and then set the clone's random to the original's random.next. Finally, our third loop separates the lists. We use a copyhead variable to track the start of our deep copy, and then we adjust the next pointers in a single pass to restore both lists to their proper form. Looking at the complexity, the time complexity is O of n, because we traverse the list 3 times. The space complexity is O of 1, because we did not use a hash map, we used the list itself to store our copies. And that is copy list with random pointer, mastered. If you want to crush your next coding interview, hit subscribe and follow Leo Academy for more premium DSA guides.